Okay, Assalamualaikum and hi guys. So now let's move on to the last chapter of this course, which is regression and correlation. So basically this chapter, regression and correlation, is about exploring the relationship between variables, right? So throughout this chapter you will learn these 6 items. So the first one is simple linear regression, then scatter diagram, least square method, confidence interval, linearity test, and correlation. So basically regression and correlation is exploring the relationship between variables. So basically we have two statistical techniques to describe the relationship between variables. One is regression analysis, another one is correlation coefficient. So regression analysis actually models the relationship between the response variable, which is y, and the predictor variable, which is x. So basically x variable, we call it as independent variable, and y is the dependent variable. So basically for regression analysis we have three models. One is simple linear regression, multiple regression, and multivariate regression. Alright, so for simple linear regression, it is done if we only have one response variable and one predictor variable, meaning that if we have only one x and one y, then we can use simple linear regression. Okay, for multiple regression is used when we have only one response variable and many predictor variables, means that if we have many x, for example x1, x2, x3 up to x5, but we only have only one response variable, which is y, so we can use multiple regression. Okay, for the last one, multivariate regression is used when we have many response variable and one or more than one predictor variable. So if let's say we have many y but we have only one x, then we can use multivariate regression, right? Okay, so basically regression analysis is a model that models the relationship between x and y. Okay, for correlation coefficient, it is also describe the relationship between variable, but it only gives us a single value, means that from a single value we can know what type of relationship that we have between the variables, which is for example, is it strong relationship or weak relationship. Okay, alright, now for simple linear regression, so the definition is a simple linear regression model gives a straight line relationship between a single response y and a single predictor x. So it is actually gives a straight line relationship between x and y variable. Okay, x is the independent variable and y is the dependent variable. Okay, example 1. An engineering student is investigating if his carry mark for all subjects depends on the number of revision hours he has spent on the subjects. So in this example, the carry marks is depends on the number of revision hours, right? So if the carry marks depends on the number of revision hours, the carry mark will be y variable and the number of revision hours will be x variable. Okay, example 2. An analyst is investigating if the increase in petrol price has an effect on the number of customers at petrol station. Okay, for example 2, the number of customer depends on the petrol price, right? So the number of customer will be Y and the petrol price is X, because this Y, the number of customers, depends on the petrol price. Alright? Okay, so now let's go to the next slide. Okay, so once we have identified the response and predictor variable, response is Y, predictor variable is X. Okay, we may select a random sample of n pair of observation. So if we have already identified our X variable and Y variable, we can now collect our data. Okay, data of Y and X. So from the data, we can come up with this model. yi equals to alpha plus beta xi plus epsilon I. So basically, this is the simple linear regression model. So y is your dependent variable, alpha and beta is the unknown parameter, x is the independent variable, and epsilon is the error. Right? For alpha and beta, alpha is an unknown regression coefficient that represent the intercept. Okay, do you know what intercept is? When x is equals to 0. So it, for example, intercept at here, let's say this y is 3. So the alpha is 3 for this example. Okay, beta is another unknown regression coefficient representing the slope, whether it is increasing or decreasing, going up or going down. Okay, so beta can be negative or positive. And epsilon is the random error. Alright, random error. So notice here that the deterministic component in the regression model above is in fact a simple linear regression or a straight line model. So basically, simple linear regression deals with a straight line graph. Okay, model assumption of simple linear regression. So we have 4 assumptions here for simple linear regression. The error are normally distributed, okay, with mean 0 and variance constant. Normally distributed with mean 0 and variance constant, and the error are uncorrelated, okay, which is equals to 0. So what does it mean by model assumption? Meaning that you have to make sure that before you proceed with simple linear regression analysis, you have to make sure that your data did not violate any of this assumption. So let's say for example, if let's say the error is not normally distributed, but and the mean is not 0, okay, the variance is constant, but you still want to proceed with simple linear regression, you cannot proceed, else you will get misleading result. Your result will not be accurate. Okay, so you have to find another model, another analysis if you have if your data is not normally distributed and your mean is not equal to 0, for example. Okay, you cannot proceed with simple linear regression, right? Okay, so basically for simple linear regression, we have this model: y hat equals to alpha hat plus beta hat x. Okay, so the estimated value of y, this is the estimated value of y hat, is actually depending on the linear function of 2 unknown parameter alpha and beta. Okay, so estimated value of y, which is y hat, is depending on the linear function of 2 unknown parameter alpha and beta. So I'll show you how to calculate, how to find the value of alpha and beta in the next video. So I think that's all for this video. See you in the next video. Okay, thank you.